Hey everybody, David the AI Guide here. Welcome to another episode. Thanks so much for tuning in. Please be sure to click the link below to get your free AI resource, because in a few short years you will be required to know some AI to do your job. This is definite, and today's story will prove it. Also, I have a new book out on Amazon. It's called The Beginner's Guide to AI. I think you're really going to like it. I hope so. So thanks so much. Please check that out and follow us on Facebook, Instagram, and Twitter as well. So today's story is technical, and for that reason, I will be reading a bit of it. But it's crucial that you hear about this because just week before last, a breakthrough was announced. And that is the world's largest computer chip. And so deep learning is a very demanding use of computer chips. So check this out. In large data centers like those operated by Google, a big cluster is as many as 48 pizza box-sized servers that slide into a single rack as tall as a person. These racks stand in rows, filling buildings the size of warehouses. So this is what AI is running on now. Racks and racks and racks full of server after server after server, all networked together. It is extremely powerful, but also inefficient. So there is a company called Cerebras, Cerebras, that has just invented the world's largest computer chip. And this is a total breakthrough. Total breakthrough. He's talking about, part of the article talks about venture capital guy who was looking at the pitch for Cerebras's chip when they were first looking for money. And he says he finally got it when he realized that the chips being used right now for deep learning are built for gaming. We've talked about that. They're by NVIDIA and they're called GPUs. This chip is an AI specific chip. That's all it's built for. It's not built to generate images or do all the other stuff that gaming chips are built for. Google has been working on this also. And they have come up with chips that are what they call a TPU, or tensor processing unit. So CPUs were the original computer chips, central processing units. GPUs were the next level, invented by NVIDIA for gaming. TPUs are the next level after that, using multiple chips. What Cerebras is doing is completely different. It's one huge chip, as you're about to see. There are also other companies working on AI-specific chips, Grok, GraphCore, and Samba Nova. A typical computer chip is the size of a fingernail. Cerebras's is the size of a dinner plate. This thing is massive. And the history is this was tried before, as far back as the 60s and then again in the 80s. So Texas Instruments tried it in the 60s, but the failure rate was so high it just wasn't commercial. And then an engineer named Gene Amdahl founded a company called Trilogy Systems, and that company made a go of it in the 80s, but ultimately failed because it was just so difficult to make one of these huge chips. Now, there's a lot of interesting stuff in this article, and I will put the link. But one of the very, very interesting things the article says is repurposing of the GPU for AI depends on the fact that all neural networks, for their sophistications, rely a lot on multiplication and addition. So these neural networks are layers of software, all numbers, matrices of numbers. And those layers facilitate addition and multiplication. So this is not complicated math. This is why my viewers can pivot, change careers, and do something in this field. But an efficient AI processor will calculate many activations in parallel, it says, and it groups them together in what they call vectors, or a grid of number or matrix, like so I was talking about. And then above the level of complexity above a matrix is called a tensor, which is where Google comes in. Ideally, you want to multiply one matrix or tensor by another in one fell swoop. That makes these chips efficient. Check out the statistics on the newest chip, which they call wafer scale engine number 2, WSE2. One came out only 2 years ago in 2019. The new one is out right now, just released. WSE2, introduced this year, uses denser circuitry and contains 2.6 trillion transistors collected into 850,000 processing units or cores. By comparison, a top GPU contains a few thousand cores, and a regular CPU has fewer than 10, and this has more than 850,000 cores, not a few thousand. This is a complete breakthrough. To top it off, there's a company that has helped Cerebras with their design called Synopsys that invented AI software, designs chips, and it solved many of the problems that the humans couldn't. So they're making this huge chip that will be exponentially faster to run AI, but they used AI to design the chip. Cores communicate faster if they're on the same chip, and big chips handle memory better. One of the big reasons that chips have been made small, the size of a thumbnail, thousands on a wafer, is the failure rate. There's a high failure rate and they could throw those away. You obviously cannot have any failure on a chip the size of a dinner plate, but you are. So what they do is they create redundancy on that single chip by having multiple of the same elements so that if one fails, it'll immediately fall over to the next one. Google, just like Synopsys, is now using AI to plan their chips, what they call chip floor planning. Google trained their AI to floor plan a tensor processing unit. They found that the AI was able to design in a matter of hours a chip, a TPU that matched or exceeded what humans had spent months working on. That's why this stuff is a total breakthrough. Everything is being sped up massively right now. These chips use a lot of power, though. Each of these chips uses enough power to run a small home, 15 kilowatts. How do they keep a chip like this that's so big from melting? The smaller chips use fans to pull air over it. This chip uses water because water wicks away the heat more efficiently than a fan does. One of these chips costs $2 million. That means only the biggest universities, the biggest research labs, the biggest corporations can use these things. So why would they pay $2 million for one chip? Here's why. CS1 solved a system equation more than 200 times faster than the fastest supercomputer. How about that? Lawrence Livermore Lab, which was involved with the invention of atomic power and the atomic bomb, uses this thing. They can simulate millions of cells at once in real time. The plant to build this chip at scale will cost $10 billion. Think about that. $10 billion for one chip plant. But the thing is, they estimate that the AI chip market is going to reach $100 billion in sales by 2025, 4 years from now. AI is exploding. That's why I started the AI Guide. I started it to bring the human impact to you. What does this article mean? AI is now on steroids with these new chips by Google and Cerebras, and the software by Google and Synopsys to invent these chips that are better than what humans can do. The rate of change is accelerating dramatically. It will soon be out of control, and we will reach the singularity where AIs can program themselves faster than humans can control them. Ray Kurzweil says 2029. This decade, the singularity will be hit, according to Ray Kurzweil, who, by the way, has an 85% accuracy rate over 40 years of predictions. So this was a long video, but it was extremely important. This is breakthrough news, and I hope you enjoyed it. Please buy my book on Amazon, The Beginner's Guide to AI. Also, click the link below. Learn about AI, people. These videos aren't enough. AI is taking over our lives. You got to learn it. Get the free resource. Everything on the resource is free. You will learn much more about AI and be prepared for your career going forward. Thanks. Take care. Follow us on Facebook, Instagram, and Twitter. And please subscribe.